Welcome to Structural Dynamics class. In this class, we will study numerical methods. So that method based on interpolation of excitation function. So outline of this lecture is methods of numerical analysis, details of interpolation method, and then we'll discuss summary. So methods of numerical analysis. Number one, methods based on interpolation of excitation function. Second, methods based on finite difference expressions for velocity and acceleration. And third, methods based on assumed variation of acceleration. So we'll discuss first method in detail in this class. So methods based on interpolation of excitation function. So now what we do in this is, now the applied force is approximated as a straight line in a small interval of time. So that is delta t is equal to ti plus 1 minus ti. So if this is a force, any arbitrary force we are taking, as you can see in this figure, this is arbitrary force, blue line, and say we are interested in say p tau. So we have two time intervals, that is time marks, that is at I ti and then I plus 1, that is ti plus 1. So force at ti is pi and force at ti plus 1 is pi plus 1, and the distance, that is time interval between these 2 points, is delta t is equal to ti plus 1 minus ti. So we need to understand one thing. We are taking this ti and ti plus 1 from a force. Okay, so that means before that also force is acting, and after this also force will act. So we are taking one time interval between ti and ti plus 1. So in between that we need to find out what will be p at any point in between, so that we will work it out. So as you can see, delta t, this one is drawn separately here. So delta t, and this is delta p. So delta p is nothing but pi plus 1 minus pi. So pi is this much quantity, and then pi plus 1 is full quantity. So we want this, so that is delta p, and this is delta t. Now how do we get p at any time instant in between ti and ti plus 1? So first of all, pi will anyway be there, and then after that we need to find out the slope of this ramp. So slope of that ramp is delta p by delta t. So delta p is pi plus 1 minus pi divided by delta t, that is ti plus 1 minus ti, multiply by tau. Tau is measured from here to here. So tau value can be 0 and tau value can be delta t. So tau's range is 0 to delta t. So if tau is 0, then our p tau will be equal to pi. Something like, if they say this is 0, then this whole thing will become 0. Then p, that tau is equal to 0 means p at ti, that will be equal to pi. So exactly same. Now if tau becomes delta t, if this is delta t, so delta t and delta t will get cancelled, pi and pi will get cancelled. It will be, we will be left with pi plus 1. So that means this function holds good for defining force at any tau in between ti and ti plus 1. Yeah. So pi is equal to delta pi by delta ti into tau. So now for undamped system, if this is a force, so how do we apply? Mu double dot u double dot at I plus ku at I, that should be equal to p tau. So this is a tau in between. Then so mu double dot at I plus ku at I is equal to p tau's function, that value we are substituting here, pi plus delta pi by delta ti into tau. Now how do you find the response to this system? Now a total response is a combination of, if you can understand, three things are there in this one. One is the impulse. Impulse means at t is equal to tau, there is an impulse, suddenly there is a jump. Okay. So that means what? Up to that point, free vibration due to initial condition. So at this point, so whatever our free vibrations are there because of the stopping of the force, at that point we need free vibration due to initial conditions. And then the second one is response to a step force. So this is a step force. And the third one is response to ramp force. Ramp force is delta pi by delta ti into tau. This is a ramp force. So three things are there: response to free vibration at this location, okay, because actually the force is coming and stopping at this point. So from we are interested at this point, so from here there is free vibration, that component we want, and then suddenly there is a step force at that point, and then ramp is also there in that. So these three quantities we need to find out. Now first one is response due to initial conditions. So initial conditions, so that means what, some force is acting up to this point. What are the initial conditions at this point? So we need u at I, u dot at I at tau is equal to 0. So at tau is equal to 0, so we are putting the tau at some point, that is at I, okay, that tau is 0 at I, tau is equal to delta t at t I plus 1. So for that we already know from impulse response function that u tau is equal to ui, that is initial condition, cos omega n tau plus u dot by u omega n sin omega n into tau. So we need to understand this one, this ui and u dot I, these are initial conditions due to the application of force up to this point. If we suddenly stop force at this point, how the system will vibrate? So let me explain you that. Say if this is forcing function t and p of t, and say we are suddenly stopping force at this point, okay. So if we suddenly stop force at that point, something like this, so that means what, response also should follow like that. So what will happen is, for response for this one may be something like this, and then after this it is just free vibration like this. So that this component is representing this free vibration, and the second component is response to step force. So suddenly there is a step force. So first one is free vibration component due to initial conditions at tau, and then second one is the step force. So we already studied from the application of Duhamel's integral or convolution integral that what is the response to step function. So you may refer to that lecture for the derivation part of this one, okay. So Pi, that is force at I by k, so this will give the static response. So 1 minus cos omega tau is suddenly this force is applied, so 1 minus cos omega tau will give the dynamic component of that, and this is a static component. So when sudden force is applied suddenly, amplitude will be double usually. So this is the step force, response due to step force, and the third one is the response due to ramp force. So this also we have studied in the Duhamel's integral, you may refer to that lecture. So u tau is equal to delta pi by k multiplied by tau by delta ti minus sin omega n tau by omega n into ti. So this delta ti is the time interval which is usually constant, and delta pi also delta pi need not be constant, but delta ti will be constant. So that means same delta t we can use throughout. So these three responses we need to add for getting the response using interpolation methods. So first one is what, free vibration due to initial displacement and initial velocity at time t is equal to tau, or at that point, and then second one is at response to step force pi, there is a sudden jump, and third one is response to ramp. So actually total force is this, as represented in the third diagram, total force is this. So we need to add these three things to get the total response at using interpolation methods. In summary, what we have discussed in this class, so response using interpolation method. So in that three steps are there. Number one, at any point of time we need to for finding response at any point of time, so we need to first find the response due to initial conditions at that point, that is one. Second one is response due to step force in the time interval, and then third, response due to ramp force in the time interval, and then add these three things. So we will get the response between time ti and ti plus 1. So like that we can go from 0 seconds up to the time till excitation lasts.